In this video, I'll be presenting our paper, which is titled Benchmarking Domain Randomization for Visual Sim-to-Real Transfer. Several works have leveraged domain randomization to transfer different manipulation skills from simulation to the real world. However, a variety of design choices must be made in order to achieve the optimal transfer. In this paper, we perform a comprehensive benchmarking study on these different choices. We aim at understanding the effect of the rendering quality on the model's transferability to the real world. Also, we aim at understanding the impact of the different randomization settings on the real-world performance. All of our models are trained with simulated data only and tested in the real world with data collected with a phone camera and labeled using Oracle. We evaluated the performance of our models using a real-world object pose estimation task, which is also a proxy for end-to-end visual control. For the first experiment, we constructed 8 different quality levels that vary in terms of 5 different parameters. Upon testing these 8 quality levels in the real world, we found that as we increased the rendering quality of the training dataset, our models tend to have better performance when exposed to real-world scenarios. However, we found with experiments that to render a single high-quality image, we need approximately triple the time compared to the low-quality ones. Thus, to overcome the expensive rendering, we proposed the use of a combination of both quality levels to combine the merits of both fast and accurate rendering. To achieve this, we trained several models with fixed data collection times and varied the percentage of each type of images. From the graphs, we can see that the real-world test error dropped significantly after incorporating as minimum as 25% of high-quality images. For the second experiment, we evaluated the importance of both textures and distractors in the training images for models exposed to novel environments in the real world. After testing our models, we found that both factors contributed to the successful transfer. Here are some examples where the model succeeded in precisely estimating the 6D pose of the target object despite the clutter and the never-seen backgrounds. However, we noticed that the model failed to generalize to cases when the real-world environment is extremely cluttered or dark. Finally, we believe that these conclusions can now be used by others in designing their own domain randomization datasets with a view towards achieving optimal sim-to-real transfer performance for a given amount of dataset generation time.